Good morning, everybody. We're going to do this 1411 practice exam. This section does not include light, though you'll see in the topic list, which is attached here, that we will be having questions on light. So make sure you do the practice exam that has light on it as well. All right, let's go ahead and get started. So it says answer the following with appropriate sig figs and put it in scientific notation. So we have to make sure that we address both of those things. Starting, if we add this plus this, we get an answer of 112.81. Remember, when you add or subtract, you look at decimal places. When you multiply or divide, that's when you look at sig figs. Okay, so here we added or subtracted, so we're looking at decimal places. This one has 2, this one has 1. That's the amount of numbers that come after the decimal. You ask which one's smaller, the answer is 1. So we underline up to the first decimal place of our answer, and we ask if the number next to it is 5 or greater. It is not, so we just get rid of it. Our answer is technically 112.8, but it asked us to put it in scientific notation. Remember, when you put something in scientific notation, the decimal's going to move. This right here is referring to normal notation, and you should have that in your notes from when we did them in class, but you want to make sure that you figure out the decimal places in normal notation. Now we can put it in scientific, move that decimal 2 times, and because we want it to be between the first and second number, and we get an answer of 1.128 times 10 to the 2. That would be our final answer in scientific notation. Move on to the next question. If you take this number and multiply it by this number, you get an answer of 2,170.602. Here we multiplied or divided, so we're going to look at sig figs. This one has 4 total sig figs. This one has 3 total sig figs. You ask which one's smaller. The answer is 3, so this answer should technically have 3 sig figs. It's 2,170. But because we have to put it in scientific notation anyways, we might as well move that number. Anytime you get stuck after multiplying or dividing, move the decimal and put it into scientific notation. So we'll move it 1, 2, 3 times, and our answer becomes 2.170602 times 10 to the third. But again, you want to make sure that we have the appropriate sig figs. 4 and 3. This one has 3. You underline the first 3. Ask if the number next to that underline is 5 or greater. It is not, so we get rid of it. So our answer is simply 2.17 times 10 to the third. All right, moving on. In these problems where you combine or mix, you have to pay attention to each step of the way. So when we multiply 24.61 times 1.39, we get an answer of 34.2079. But again, we multiplied. When you multiply, you look at sig figs. This had 4, this had 3, so technically this answer should have 3. But do you round in the middle of a problem? The answer is no. You keep those. You keep them. You make sure that you use them in the calculation. And in fact, to make sure that I really encourage this, when I find my calculator. So if you're watching this on mute, you actually see me do it. So again, we say 24.61, whoops, times 1.39. Then I get this whole answer, to which I'm going to add 2.0000, 2 with 5 zeros. So in other words, plus 2. The zeros don't count, but if you really wanted them to, you could do that just to stay consistent in case you're uncomfortable with when zeros count or don't count. Okay, and that gives me an answer of 36.2079. Now we have to figure out sig figs again, but now we added something that we only knew up to the first decimal to something that we know to 5 decimal places. The one with 1 decimal place wins. Make that one better, and that's why we underline just 1 decimal place here. Ask if the number next to it's a 5 or greater. It is not, so we just go ahead and get rid of it. 36.2 would be our answer. In scientific notation, that would be 3.62 times 10 to the 1. All right, now we do this one. So here we are adding first. So if we take 24.61 plus 1.39, we get an answer of just 26. But we've added, right? And when you add, you look at decimal places. Now this one has 2 decimal places, and this one has 2 decimal places. So how many should our answer have? It needs 2. So what do? You add 2. You literally put 2 in there. So to make sure. So now we know that this has we know this all the way to 2 decimal places. Now, when we multiply it by 2, we get an answer of 52. But again, this now, when we multiply, has 4 sig figs, and this one has 6 sig figs. Our one with 4 is smaller. So even though we get an answer of 52, we need to have 4 sig figs. So it's 52.00. We put that in scientific notation by moving the decimal 1 time. 5.200 times 10 to the 1 is our final answer. All right, moving on to the next problem. Next page. Encounter this. It says how many ounces are in 500 grams, and it gives us the conversion. I will give you all the conversions you need, okay? So what we're starting with is 500 grams. Remember, when we rewrite these conversions, it's easier to see them if we use that horizontal line. Okay? So we're starting with 500 grams. We know if grams here, then we must pull gram here, and 0.0353 ounces must go there. So all we're doing, anything on the top gets multiplied, anything on the bottom is a division. So 500 times 0.0353 gives me an answer of 17.65. Now, when we do conversions, generally, even though this technically really has 3 sig figs, we said in this class when we do conversions, this would have an infinite number of sig figs. And this one right here is a measurement. 500 grams is a measurement. This one only has 1 sig fig. So your final answer, when you're looking at 1 versus infinity, should be just 1 sig fig. Okay, so your answer is technically 20. If you got $17.65, it rounds up to 20. If that was hard or scary, then always put it in scientific notation first. Then underline the first number because you only need 1 sig fig. If that number is 5 or greater, you round up. So 2 times 10 to the 1. Either one of these answers are acceptable. They're the same. All right, moving on to deciliters. So to megaliters, so we're starting with megaliter and we're turning it into deci. If you remember, mega is 10 to the 6 and deci is -1. We always subtract. 6 minus -1 would give us a positive 7, so our answer is 8.7 times 10 to the 7 deciliters. If you prefer to do it an alternate way, which I don't blame you, or you do it in any other way I've taught prior to this class this semester, it's like this. 8.7 megaliters becomes 8.7 times 10 to the 6 liters. You know that there are 10 to the -1 liters in a deciliter. You have a 6 minus -1. This would be, or a 10 to the 6 divided by 10 to the -1, I'll slow down, is 8.7 times 10 to the 6 minus a -1. That's the same thing as adding. In other words, 8.7 times 10 to the 7. Our liters have canceled, and the only unit we have left is deciliters. So both ways will provide you with the same answer. In fact, you're just doing a shortcut here. You're taking the top number divided by the bottom number. Here's the top number and the bottom number. So it should work out. All right, moving on. How many feet are in 285 centimeters cubed and feet squared? So we said, okay, we'll start off exactly the same way you would normally, where if this is centimeters, you know that there's 2.54 centimeters in an inch. And if this is an inch, you must put inch here. There are 12 inches in a foot. But if we went to cancel, we'd realize centimeters squared and centimeters are not the same thing. So you have to square it. And you can't just square the unit. You got to square the number and the unit, everything in here. And now we squared inches, so they don't cancel here. So we got to square the 12, square the inches, square the foot, and that's going to give us our answer. In other words, if we were to write this out, we have 2.85, or excuse me, I don't know why I said 2.85, 285 divided by 2.54 squared divided by 12 squared. Remember, anything on the bottom gets a division sign. So there are many ways I can do this. Like I said, I try to avoid using squares, so I'll just say 285 divided by 2.54, divided by 2.54, divided by 12, divided by 12. And it gives me an answer of 0.30677. When we're looking at sig figs, this has 3. This is a conversion that is infinite. This is a conversion that is infinite. 3, infinity, or infinity. 3 is the smallest. We underline the first 3, 1, 2, 3. Ask if the number next to it's a 5 or greater. It is not, or it is, so we round up. Our answer is 0.307 feet squared. You could also put 3.07 times 10 to the negative 1 feet squared if you'd like. Moving on to the next question. How many protons, neutrons, or electrons are in 23 Na+? So this sodium ion indicates that it has a positive or negative charge. It's called an ion. And here, this indicates the mass number. Remember, that's protons plus neutrons. So protons is straightforward. You can figure out protons very, very quickly simply by looking at the periodic table and determining that it's number 11 on the periodic table. That will tell you the number of protons. So sodium has 11 protons. And I like to write it right there. The reason I like to write it right there is it makes it really simple, because if that's protons, number of neutrons, you just take this number, the big number, minus this number, the smaller number, and you get an answer of 12. That happens to be the same. And last but not least, we look at electrons. So electrons, remember, are negatively charged. Protons are positively charged. So if we have an overall positive charge, that means we have an extra proton. That means we must have one less electron, which means the only way that works is if we have 10 electrons. You can never change the number of protons. This always has to stay the same. Only this can change. All right. Moving on, what is the molar mass of HNO3? So I told you you can generally rule to round to 2 decimals is fine, but I told you except hydrogen. The reason for that is oftentimes there's many, many hydrogens, so if you round in the middle of the problem, it ends up affecting the overall answer. So for hydrogen, you generally want to keep it as 1.008. So the molar mass of this would be the mass of hydrogen, which again is 1.008. There is only one hydrogen. There's only one nitrogen. That's 14.01. You are okay to round with nitrogen. There's generally not enough nitrogen to affect the overall end result. And oxygen, there are 3 of them, and they round to 16.00. Okay, so this is 48, 58, 63. So you get like 63.018 should be your answer. But then I told you 2 decimal places is fine, and that makes sense because you added 3 decimals plus 2 plus 2, so this answer should have 2. That number is greater than 5, so you round up. 63.02 grams per mole would be your answer, and you want to keep it in grams per mole. We've talked about AMU before we introduced it, but grams per mole is generally the unit you'll always use for molar mass. Okay, last but not least, how many total atoms? Remember, to do this, we go grams to mole to molecule to atom, and you should be able to go backwards as well. To go from grams to mole, we'll need that 63.02 grams per mole because we're talking about HNO3. To go from mole to molecule, you need to know that there's 6.022 times 10 to the 23rd molecule in a mole. And to go from molecule to atom, you need to know how many total atoms there are in a molecule. In one HNO3, there's an H, there's an N, and there's 3 oxygens. So there's a total of 5 atoms. Okay. So there are 5 atoms per molecule. Keep in mind, I could have asked about oxygen atoms, so I could have said there's 3 oxygen atoms in a molecule. I could ask this question many, many ways. All right, with this information, now we can go ahead and begin. We got 45.3 grams. We know if this is grams, grams from up here is going down here. And then mole must go on top, so we've used this. Now we're in mole town. If this is mole, mole must come down here. It's right there. And then 6.022 times 10 to the 23rd molecule must go on top. Now we've used that. If this is molecule, molecule must go down here. and there are 5 atoms. I'm going to show you how I calculate it. With the calculator I suggest you guys got, so 45.3 times 6.022 times 5 divided by 63.02. And I get an answer of 22 point, but I notice I didn't use that times 10 to the 23rd. So I usually do 22, I know it needs 3 sig figs, so I'll do 22.4 times 10 to the 23rd. But this is 2.24 times 10 to the 1, and then you have a times 10 to the 23rd. In other words, 2.24 times 10 to the 24 atoms. Now you could also have, if you didn't want to do the way of leaving the 10 to the 23rd out, you'd do 45.3 times 6.022 times 10 to the 23rd. So just use the little 2 button, times 5 divided by 63.02, and you'll get the exact same thing, 2.16. 2.16 times 10 to the 24. I must have messed up in something, so let's see, what answer do I have? Oh yeah, 2.16. So this is 21.6. 21.6. 2.16. The rest of the stuff was fine. So if you do that right now, you get 2.16 times 10 to the 24. So it doesn't matter which way you do it, if you leave the 10 to the 23rd out and add it later, or do it in the middle of the problem, which is what I suggest if you're most comfortable with it, you get the same answer. All right, guys, hope that helped. Have a good one.